Hey, everybody, welcome to the first support show. We're here to give you an idea of how to run your machine, let you ask questions, and cover some basic topics. We want you to win with your machine. That's simple. Everyone's welcome, but it's mostly for our brand new family members. Ask questions at the end of each topic, ask questions at the end during the open forum. There is no question that is too stupid or shouldn't be asked. We absolutely should be asking anything you want to know. We're going to do these 2 times a month on Fridays at 3 p.m. as we are now. We'll have 2 featured topics. Then we will have an open time for questions. We'll open for any question at the very end, anything you want to ask. People you already talked to, if you email support@carbide3d.com, you're going to get one of the team members who are hosting one of these shows. And this is the one thing you're going to do with a Shapeoko that does not require safety glasses. With that primer, let's get you started on this one. Today's support host is Nick Meastas. In addition to machining and doing support here, he has an extensive 3D printing background. He washes dogs on the weekend, and you might find him cooking over a hot plate in the break room if you spend a little time here at Carbide 3D. So if you want some s'mores or some support, Nick's got you covered. Our topics today are testing materials and troubleshooting cuts. Take it away.
Thank you, Kevin. Today we're going to go over why we test materials and just kind of giving a general information on that kind of stuff. So let's hop right into it. Why we test materials. So this, to me, is one of the most important things that you can do with your machine, especially when you are first getting started, when you're trying to figure out, hey, why isn't my machine cutting properly? What is going on with this? So 100% of the time on any machine that I've ever ran, that being a CNC, a laser, a 3D printer, even in embroidery machines, vinyl cutters, all sorts of stuff. Every single one of those, you want to test your materials. And it's really important because you'll become familiar with how the materials cut and basically how to optimize cutting them. So the first thing that I want to stress is that when you go and you get new materials, you want to order extra materials. And I like to call it learning material because basically you're going to be learning with it. And I know sometimes certain materials can be kind of expensive, so get whatever you can that's close to it. But 100% you want to test every single thing that you do, at least until you're familiar with kind of like how hardwood's cut, or like MDF, something like that. I actually keep MDF on hand just because I think that's an excellent material to cut in, and you're not going to damage your end mills or anything of that sort. But the other thing that you want to make sure of too when you're testing materials is that you're going to be able to test different end mills in that material because each end mill behaves differently in the same material. So if you take a V-bit or something of that sort in comparison to like a flat end mill, you're going to get a completely different result depending on the feeds and speeds that you're using. So like our 301 and 302 V-bits, they're designed pretty much for wood. You can use them a little bit on plastics for chamfering, but we don't typically recommend using them on anything other than woods. And that was one of the first things that I learned was cutting an MDF with a V-bit. I think that it's an excellent place to start. And Carbide Create has built-in speeds and feeds for that type of material, and they're pretty conservative, so we test them pretty often, and it's something that we can just about guarantee is going to cut properly if you use the speeds and feeds that are in there. You want to use flat end mills, and basically the different amounts of flutes on the end mills can determine the surface finish when you're cutting. So that's even something like that, even if the size of the end mill is the same and the type of end mill is the same, the different types of flutes can change how it cuts. You want to use on wood, you want to do something between 2 and 3 flutes typically. You can use other sizes, but that's what I would recommend. Soft plastics are going to be the same. You're going to want to use 2 to 3 flutes. On hard plastics like acrylic, you want to use a single flute because you want it to be more of like a cutting action and less of like a grinding action. Now, just to do a quick little blurb on hard plastics and soft plastics, they're pretty difficult to cut. And it's honestly, I would say that material is subjectively harder to cut than a lot of metals are. So definitely take your time when you're learning plastics. Go slow and dial it in. Don't try to go full speed on something like that, because it definitely there's a lot of factors that can determine how well it cuts. And just take your time and learn the materials. Metal, you're going to want to use a single flute on that as well. You can use like a 201 end mill to cut metals. Like we have a Z-coated one when you're doing aluminum. And I think it works great. I haven't ever had any issues with something like that. And one thing that I've seen before in a couple onboarding calls is where people have gone and they've purchased end mills, and a lot of them, there's a lot of places that you can purchase them at, but they don't really give too much information. If you're doing if you purchase a downcut end mill, that is pretty much for wood only. You don't ever want to use something like that on a metal, just because it's not good. So that's all I'll say about that, because it's I don't think you're going to get any kind of good results out of using a downcut on metal. So the size of the end mill will also determine how it cuts. So I know a lot of people like to use a really large end mill when they're surfacing, just because it's faster. But I like to use the smaller end mills just because I think you get a little bit more even of a surface finish when you use the smaller end mills. And when you're doing contour cuts, the way I like to think about it is the larger the end mill, the more material it's having to move. So the more you're going to run into resistance. So the smaller the end mill that I can use when I'm cutting contours, while keeping it as rigid as I can, the better. I know a lot of the times when I cut stuff that's like aluminum, or I cut a lot of brass, I make a lot of jewelry. So I'll opt for a 16th inch end mill if I can in the material, in comparison to using something like an 1/8 inch. So like I said before, I would just keep the speeds and feeds that you have in Carbide Create, and just go with those because they're super conservative. You can go and do your cuts, be confident with it. Just get out there and do the cuts. I know we're trying to make this as efficient as we can. So tweak as you need during the cuts. I would say on your first cut that you're doing on a material, you're going to want to stand there and watch it. And I know that can be something that takes quite a bit of time, especially if it's a larger cut. But you definitely want to listen to how it sounds, see how it's cutting, and adjust on the fly so that you can make sure that you're doing everything efficiently and optimized. Another thing that will change how your cuts are is dependent on if you're doing like a 3D cut or a 2D cut. Those are completely different and should be addressed completely differently. So just make sure that if you're using the same material and you're doing a 2D cut, you want to definitely also check when you're doing a 3D cut as well. So the other thing that I want to go over is how to test your materials. So I use a test file, and I can show you guys real quick. I put notes on my test files so that I know what I'm doing, and so I've seen it before. So this is just basically saying that where my zero is set for my test file. I recommend, if you guys are doing a test file, to put something like this so you know what you're doing. When you pull it up, it's not like a question of what Endmill I'm going to use, anything of that sort. But it's a simple file. I just do a circle and a square, and I do it as a pocket. This one is set for hardwood because this is what I test primarily. But you'll see it's quick little 3-minute cut. And the reason why I use this type of cut is because I can measure the width of these, and I can also see surface finish on the bottom and on the edges of the cut. So this gives me a really good baseline of how something is cutting, and it's quick. I can do it on multiple pieces, and it's just something that I always recommend, especially with our new users. I do a lot of the onboarding calls, and this is something that I always recommend, to have a file like this where you can just cut it out real quick. And then the other thing is, if you're doing the same file all the time, once you've got a material dialed in, you can compare materials and see exactly what may have gone wrong, or if I can speed it up a little bit, this looks like it's cutting perfectly fine, something of that sort. And you can also run your projects. Let's say you have a huge project you're trying to do. You can break the project down into like little pieces and just do a little bit of it at a time, just to test to see how that cut goes, and just to test and see if you're doing something like inlays, how it's going to fit, how hardware is going to fit, that kind of stuff. And you also want to have something that, like I said earlier, like this cut, or let's say you have a project like a catch tray or something that's useful that you're going to use. Cut that out, and I mean, test with it, give it as a gift. It's definitely something that that I'd recommend. And typically it takes at least 3 times on a project to get it dialed in. So I'll do a first cut. It's usually kind of rough. I look at it, I go, okay, let's dial it in. I'll do a second cut. It looks better. And then I'll do a third cut, and that third one is usually right where I want it. So it takes a couple times to become Instagram proficient. So just remember, like I said before, order extra material to test your stuff. Testing should be done on all materials, and this allows for better optimized and safer cuts. So I mean, that's all I have to say on that. I guess we'll open it up for questions here.
Nick, I've got one. So how often do you think are you testing your cut shape of your design versus testing a material when you're doing a new project?
I would say I do both kind of frequently. I test a lot. Usually I'll test the material on that with that circle square test. And once I get something that is semi decent, then I'll hop in and I'll start cutting something that, or part of one of my designs, because I think that that circle square test is something to start off with just as a baseline, because it takes 2 or 3 minutes. If I can get that cut out real quick and get it to somewhere where I'm happy with it, then I can continue on into breaking down my design into something smaller and just doing like a test on it. I mean, when I have a project that takes several hours, I don't want to run that multiple times. So I want to cut the little pieces that make sense, and then or the most important parts of it, and then go from there.
How much does work holding of a material affect your project plan?
I would say work holding is a huge part of the project plan, especially if you're doing something that is something that needs to be mounted down to your wasteboard. There's a lot that goes into it. I mean, Winston will tell you, I've seen him do wasteboard designs, and I mean, that kind of stuff kind of blows my mind when he's doing something of that sort. But a lot of the time, if I'm doing something that is like on a Nomad, your build plate is 8x8. So if I have something that is 7.5 by 7.5, I'm going to have to figure it out because clamps aren't going to work. And I mean, a lot of the times I'll have something like I'll drill a hole and I'll mount it down. It just depends on what I'm doing, but I think it's very important to kind of figure that out when you're doing your design in Carbide Create or wherever you're doing your design at, and making sure that your clamps and your tabs and everything line up. Because I've ran into clamps before. I mean, we all have. That's the that I think that's one of the badges that you get when you cut a clamp in half while you're doing a a design. So yeah.
Yeah, I think one thing I'd note in there, people need to think about the cutting forces at work as it relates to their work holding. When we're talking about materials, going through an aluminum or an acrylic is going to be a lot more force applied to that stock, however it's held, than it is for an MDF. And obviously MDF different than walnut or maple, something of that type. You want to be aware of how much holding force you need, and definitely have way more than you think you need.
Yeah, I agree. What is a good end mill for various and multiple uses? My favorite end mill that I think that we carry is probably the 102, the 1/8 inch. And I think the 201 is also excellent. I think flat end mills are probably one of my favorite when it comes to versatility with end mills, just because with those end mills, you're going to be able to do pockets, you can do contour cuts. There's just a lot that you can do with that type of end mill. The other one that I really like is I use a 501 and a 502. Those are PCB end mills. And I use those for engraving on jewelry and that kind of stuff all the time. And I think they're pretty versatile when it comes to what they can do. So, but it just depends on what you're kind of working on. And that's why we typically recommend, if you have a question on a certain project or what you're trying to do, to just shoot us over an example and we can kind of give a little bit more insight on what we would recommend. Troubleshooting cuts, I think, is a very helpful skill to have, especially when you get a little bit experienced on cutting stuff. And I mean, you can always look up, or you can always reach out to us and we can kind of explain if you've seen something during a cut that didn't seem right. But examples of failed cuts can be something like drifting, fraying, scorching, and melting. And those are all symptoms of either something mechanically wrong or something that is speeds and feeds wise, there's something that's going on. So drifting typically happens when your speeds are too high, and or the machine is not mechanically sound. So doing tech support, we get a lot of calls where someone they're doing a cut and they're doing lettering, and the lettering spacing is just completely wrong. And 99% of the time, what ends up being the issue is something mechanically where they haven't done like a pre-flight check, which is where you just go through your machine to make sure that everything is tightened properly, to make sure your belts are tightened. But it's always something like a set screw is loose, and that allows the x-axis to drift. Or they're cutting at too fast of a speed. They've accidentally selected something like a softwood when they're cutting a hardwood, and the machine skips a little bit during a cut like that. We don't see that too often on like the HDM or like a Shipoko 5, but it definitely can happen if you do or if you move too fast. And something like fraying, you'll see that happen if the end mill gets kind of dull. You'll see like a weird, I mean, it's basically fraying. Or if your material's wet, like I've had a couple times where I've gone to one of our big box stores out here and purchased wood, and the wood is still wet from when they cut it. And I go to cut it like a poplar or something like that, and it gets all this fraying all over the place. And I mean, it doesn't bother me too much because I do somewhat of a post-processing on it, but I know it bothers some people, and it can also be a telltale sign that your end mill is dull. So definitely, this is another reason why it's important to kind of know your material, is because you'll know if A, this is just how the material cuts. Um, Scorching comes from if your spindle speed is too high or your travel speed is too fast. So you'll see the wood it'll just have like little burn marks on it. And the burning, I've seen it before also when the end mill gets a little bit dull where it's not cutting as well. But if you see something like that, definitely slow it down. And again, double check to make sure that your end mill is sharp. They do need to be replaced at some point. And you'll also see melting is kind of similar to the two, but it's with plastic. So if you have a cut and in something like acrylic and you see it start melting, just double check the speeds, because it's a lot easier to melt material than it is to scorch it, but I've seen both. So typically what I recommend if you do find something like that is to run the project at 50% speed and see if you can get it to work at that speed, because if you run it at that speed, you shouldn't have any issues cutting. And then also you can always do a test cut in something like MDF to see how it cuts at the regular speed. MDF is pretty forgiving, so I always recommend to have some of that on hand just so you can test and see, hey, my cut failed. Let's try it out on some MDF and see if we can get it to work. So the next thing after I've checked those couple things is I check my design. There's times where there's certain portions of a cut where it'll fail because there's unintended errors that I've accidentally put. I've selected something that I didn't mean to select, and it may cause errors in my cuts. Most of the time, I'm less inclined to think that the software has calculated something wrong. It's usually pretty good with designs. I mean, of course, everything like that is going to have bugs, but it's very, very rare to find something in there where the calculation in the software is off if the parameters for the machine and the parameters for the end mill and everything are correct. And like we spoke out before, or spoke out about previously, is that you have to check your work holding. I mean, I couldn't tell you how many times I've started a cut and gotten 90% of the way through it and it's failed because the work holding has come loose. I mean, there's been times where I've used double-sided tape while doing a like an aluminum cut, and the aluminum's gotten hot and melted, and or not the aluminum, the double-sided tape has gotten hot, and it's caused some issues. And then also, again, always check to make sure your end mills are sharp, and just go through your machine and make sure that it's mechanically sound. That's as I mentioned before, you want to do a pre-flight check. I always check everything on my machine before I do some cuts, and it's like maintenance on your car. You want to just make sure if there's anything going on. So yeah, I mean, that's how I typically troubleshoot. And then what this troubleshooting goes back to testing material. So if you're noticing the same issues over and over in a material, then go back and test the material, and until you get that fixed, then go back to cutting, and then just rinse and repeat when it comes to troubleshooting. So yeah, I guess I see that we have a couple questions there, so I guess we can go ahead and answer those. So I see Kevin said, for surface finish, what should my expectations be when I'm new to CNC? Surface finish, I would say when you're new and you're just starting out, surface finish, it varies from material to material, but I would say that if you're expecting to cut, like I said, I do jewelry. I don't expect that when I cut something out of brass that I'm going to peel it off and it's going to be polished and um 100% ready to go. There are times where I've done signs before where I've cut them out and I'm like, yeah, this is great, and with minimal sanding or minimal of something that sort. But I would say that your first couple cuts and your first couple designs probably will have a few dings and chips and things here and there. I do a preview of my project before I cut it out. So in Carbide Create, there is a section in the toolpath area that has a simulation that you can take a look at, and it'll give you an idea of what it's going to do when it's cutting. There's also in Carbide Motion, you can take a look at a similar simulation to kind of give you an idea of what's going on. And I always check that. And I check in both spots just because I want to make sure that I didn't oversee something or I didn't check. And it's also a good time to make sure that my work holding is going to work properly based on what my cut's going to be. So those are two places you can look to view a simulation. I would say Ed here said, how would you treat feeds and speeds for epoxy? I would say that they're going to be similar to a hard plastic, though I think that epoxy, I actually think is a little bit easier to cut than at least when I've done it in comparison to like an acrylic. I think that it's kind of in between a hard and a soft plastic, but again, I would test it because it just depends on which epoxy you're using, and it depends on the mixture. There's a lot that can go into it. So what I would do is I would probably get one of those little silicone molds and just do a little brick of epoxy and then do a test cut on it and see what you get out of it, because like I said, it depends on where you're getting it from and kind of how it is, because there's quite a few different types of epoxy that are out there. When mistakes occur in a project, what is the first thing you check? The first thing that I check is my file. So I typically will take a look real quick and just double, triple check to make sure that error doesn't show up in the simulation. If it is a error as in, let's say I was cutting out some text and a piece of it got cut off that wasn't supposed to be cut off, I double check to make sure that the tolerances and what I am cutting is capable of holding something like that. Like if you're cutting a piece of MDF and you're cutting lettering out and a portion of it is like, a 1/16 of an inch, you have to be pretty delicate with cutting around that. And I would also say that you'd want it to be something that where you would probably use a smaller end mill so that you're not having so much force that's dragging across it. So that's probably what I would check first, is that kind of stuff. And then I would go back and probably test the material if I did find something of that sort. And you could always take that portion of it that failed and run it as a test. I mean, you can get some MDF and see if that's what's causing the yeah, I agree. The resolution of the material, because you never know. The material just may not cut like that. I mean, there's some materials that just aren't really great at cutting the smaller detailed stuff, and that goes across the board for all machines. I mean, I had a recent project with a vinyl cutter, and I underestimated the ability of that, or I overestimated the ability of that machine, and I was unable to do some of the smaller details. And I mean, it's just I had to go back and test that material until I got something that worked. So I would say definitely keep an eye out for little things like that, and again, test the material, test that portion of it until you get a a product that you like, and go from there.
All right, right on, Nick. Thank you for that. I don't think we have any more questions for that particular topic. We'll open the floor for anyone who wants to ask a question about anything. What's bothering you? What are you struggling with? What are you approaching this weekend on your project? What do you need?
I mean, I could go over a couple of the things that, so typically when I do an onboarding call, the most common questions that I get with starting off is, where do I start, and how do I get my feet wet with a project? And typically what I recommend is, we have the My Carbide 3D website. And that is an excellent place to start, especially if you haven't had any kind of experience with it. It's it's definitely a good place that we have a couple projects on there that you can run real quick. Oh, how do we schedule an onboarding call? The onboarding calls, you can do them through I believe it's on our contact us section on our Carbide 3D website. And I believe they're also on, I want to say they're on My Carbide 3D. I'd have to double check. But there is a link on the contact us section where you can set up an onboarding with us. And I recommend it to anyone that just wants to hop on and have some questions. An expectation that is important is that a lot of people want to get on and run a really complicated design right off the bat. And I understand, you're super excited. You got a new machine. You want to do all the complicated fun cuts and all that stuff, but it is very important that you learn your material and you learn your machine. I mean, I'm one of those people that I'll spend a whole day, 8 hours testing a material just to get it right before I start doing something. So I always recommend that before. I mean, I always encourage to hop in and test stuff, but also know that you're gonna have to put some work in and learn kind of what's going on with your machine. And I mean, it's the same thing as if you were to go out and to purchase a car. You're not going to go and join an F1 race when you get your driver's license. So just be patient and learn your material.
All right, Nick, I think that's about it. If we don't have any further questions, I don't see anything else in the chat, and no one else has asked a question. So that's great. Thanks for being a part of this. Our next support show will be on the 28th of April. Tell your friends, tell your neighbor, tell your grandma. I don't know if she's into CNC. She could be. And thank you, Nick, and we'll see you in the weeks to come. Thanks, everybody, for being here for Support Show 1.